Hi everyone. Welcome to our second lesson in 3.0 Introduction to Trigonometry. In the second part, we're going to be looking at similar triangles and how to tell if two triangles are similar. In other words, are they congruent? That's another word for similar. Or are they the same? So congruent, it's another word for similar. We should write that down because if you move on to Math 11, you're going to see that word in the future. Okay, and any two shapes that are similar are not the exact same, but we can say that they have matching ratios if we compare their side lengths. Okay, so things that are congruent are not the same, but they are similar. And we're going to talk about how to look at two triangles here and decide whether they're similar or not. And what's interesting is this method that we use to compare their side lengths, and in the case of a triangle, we can also compare their angles. But comparing side lengths works for any type of object. If we're interested to know if two objects are similar or congruent, we can simply compare two dimensions, okay, that are the same, and figure out what is the ratio there. Okay, whatever that ratio is, it should be true for all the other dimensions. So, for example, height, radius, length, width, any dimension that we choose to compare. Okay, so similar triangles. We're just going to look at triangles at the moment, and similar triangles have angles that are equal. So if two triangles are similar, one might be bigger than the other. So you could see here, if you look at these two triangles that we have, the triangle ABC looks to me like it's a little bit smaller than triangle DEF. So we know they're not the exact same. Okay. However, we could tell if they were similar by starting at looking at their angles. They'll have the same angles. Okay. They should be matching. And when we measure individual side lengths, we should find that the ratios of the sides are equal. So let's go ahead and break this down for ourselves and talk about this. Okay. First of all, these triangles are similar because their matching angles are equal. So we should be able to look at two triangles and compare their angles. And it doesn't matter that triangle DEF has been turned. Okay, so if I were to compare these, if I were to rotate this triangle here, triangle DEF, I could see that if I rotated it, it would actually look something like this. Okay, if I kept and if I took D here and I rotated it all the way up to here, okay, so that it looks like this now, D, okay, E, F. If I did that, I would see that, okay, their angles are actually in the very same position now, so it's maybe even a little bit easier to compare visually. Okay, I can see now that triangle ABC and DEF are in fact similar because they have the same angles. Now, even if you don't rotate that, you can still check if they're similar because you'll see that they should have three angles that are the same. Okay. So 40 and 40, 110, 110, 30, and 30. So angle B is equal to angle E. Okay, angle B and angle E, they both equal 30 degrees. Angle C on my triangle 1 is equal to my angle F on triangle 2 because they both equal 110 degrees. And finally, angle A is equal to angle D because on both those triangles, there's an angle of 40 degrees. So right away, this tells me that these two triangles are similar. I don't even have to rotate the one triangle. Okay, I just did that to show you. So the first thing we can do is compare the angles, and if the angles are the same in both triangles, that is telling us that those are similar triangles. The other thing that I can do here is I can compare their side lengths. Okay, so we're going to look at the ratios, okay, of the sides. So what we're going to do is we're going to take two sides that are matching. Okay, so in other words, I'm going to compare the longest side for both triangles. So I look at my triangle A, and this is something that can be done visually, even if you don't, I mean, generally you will actually, you have to have the measurements here so you can look and say to yourself, oh, there's the longest side. I can see that it's longer than the other two sides. But even by like visually inspecting a triangle, I can see that that side there from A to B is the longest side. Okay, so I'm going to compare that, and I'm going to write it as a ratio. So it's going to be triangle for all of these. When you're doing ratios, you're going to show the dimensions of either triangle 1 over triangle 2, or, okay, you can also do that the opposite way. So you could put triangle 2 on the top when you write your ratio over triangle 1, and that's fine too. As long as you're consistent, it doesn't matter. Those are both totally acceptable ratios. I'm just going to go ahead and put triangle 1 on the top and triangle 2 on the bottom. Okay, so I'm going to say the longest side on triangle 1 is A to B, and I'm going to write that as a ratio over the longest side on the other triangle. So on the other triangle, I can see that E to D is my longest side. So I'm going to, if I knew these values, I would put them in. Okay, and that's going to come up, that's going to give me a number, and that's called the ratio. Okay, for the longest side. Then I'm going to compare the short sides. You're just going to compare all of the dimensions. Okay, well, let's see. On triangle 1, or ABC, it looks to me like the short side is probably this one right here, A to C. Okay, there's the shortest side over there. And on the other triangle, the shortest side looks like it is from D to F. Okay, and again, when you have the measurements, it's really easy to see that. Okay, so keeping consistent with the ratio that I just did, I'm going to put the short side for triangle 1 on the top. So that's going to be the length AC. And on the bottom, I'm going to put the dimension of the short side of triangle 2, which is from D to F. Okay, and that again, when I divide the top by the bottom, I'm going to get a number. And that's the ratio. Finally, I'm going to look at the leftover side, so the other side. Okay, the third missing side. And so that would be B to C for triangle 1. Oops, sorry. And on triangle 2, that's going to be this one right here from E to F. Okay, and again, so I put in the lengths, whatever they are, divide the top by the bottom, and I get a number. If these triangles are similar, this number will be the same. Okay, so the ratio that I get for all 3 side lengths must be the same. Okay, so we should get the same ratio, and the ratio is the number that we get from writing this as a ratio and dividing the top by the bottom. Okay, so for all 3 sides. So in other words, I should get something like, 5, for example, 5 and 5, or 2, 2, and 2. It doesn't matter what that number is, it just has to be consistent for all 3 sides that I compared. And that just tells me that if the number came out to be 5, it tells me that triangle 1 on the top here is 5 times bigger than the bottom. We would expect for this to be a number less than 1, because it looks to me like the first triangle is a little bit smaller. And so I might get, 0.5 or 0.9 or some other number less than 1 here. And that tells me that triangle 1 is 0.5 times smaller than triangle 2. Okay. Let's go ahead and just try a question now with some dimensions. So here's 2 triangles. Let's ask ourselves, are they similar? We're not given the angles. If we were given the angles, that's a really quick way to compare them, because we simply just compare the 3 angles, and if we have 3 of the same angles in both triangles, in other words, they share the same angles, then I can say they're similar. I don't have the angles, so I'm going to have to compare the lengths of each side. So I'm going to find the ratios, okay, of the sides. So remember what we did. We start with the longest side. Okay, we don't have to start with the longest side, but just makes it easy. So we're going to compare the long side. So for triangle, let's call this triangle 1 and this triangle 2. Okay, and let's write it. Let's put triangle 1 over triangle 2. It really doesn't make a difference. You could do it the other way as well. Okay, so the longest side of triangle 1 is right here, 12 centimeters. It's longer than the other sides. Triangle 2, the longest side is from S to T, and that's 5 centimeters. Okay, so I'm going to write, let's put triangle 1 on the top. So that's going to be from Q to P. Okay, and I'm going to put triangle 2 in the bottom, so that's from S to T. And the numbers are 12 centimeters over 5 centimeters for triangle 2. And if I take 12 and I divide it by 5, I'm going to get the number 2.4. Okay, that's the ratio of the longest sides. Now we're going to go ahead and do the short side. So I'm going to just compare the short side of triangle 1. And if I look at it, that's from Q to R, that's 6 centimeters. Okay. And on triangle 2, the shortest side is from U to T, which is 2 centimeters. And 6 divided by 2 is 3. Notice that my centimeters here are canceling. A ratio never has units. So I have 2.4 for the first ratio and 3 for the second ratio. Right away, I know that these two triangles are not similar because the ratios are not the same. So if I had seen 2.4 again as my ratio for the short sides, then I would keep going and check the last side. And I would, hopefully, if I had the same ratio, then I would know that they were similar. If we wanted to, just confirm it, although I already know they're not similar because right away I've got two different ratios. But the last side that you would compare is the other side. And for triangle 1, that would be 8 centimeters from R to P. And for triangle 2, it would be from S to U, and that's equal to 4 centimeters. And so this time I get 8 divided by 4 is 2. So all three sides have different ratios. These two triangles are not similar. I'm going to ask you in your notes, you have a check sheet which has 2 questions on it. I'd like you now to try the second check, which is, are these triangles similar? And so you aren't given angles here, you're just going to do the ratios. There's 2 sets of triangles. So for A, you're going to compare the longest side, the shortest side, the other side. And for B, you're going to compare, again, the longest, shortest, and other side, and ask yourself, is that ratio the same? Okay, for each of the sides. Excellent. Thanks for joining me today. Good luck. Bye for now.